Computer science is a blend of application, computations, and mathematics. It is the mode of scientific investigations that supplements the traditional laboratory and theoretical methods of acquiring knowledge. This is done by formulating mathematical models whose solutions are approximated by computer applications. This can be possible only with the help of computational softwares such as MATLAB Mathematica, Scilab, Maple, Python, etc. MATLAB Mathematica and Maple are so commercial software, whereas Scilab, Python, and R programming are open source software which are free available and can be easily installed to computing. This course is based on the introduction to computational mathematics with Python. Python is interpreted object-oriented high-level programming language. It's a high-level built-in data structure combined with the dynamic typing and dynamic binding make it very attractive for rapid application development as well as for use as a scripting language to connect existing components together. The Python interpreter and the extensive standard library are available in source or binary form without charge for all major platforms and can be freely distributed. SymPy is a Python library for symbolic mathematics. It aims to become a full-featured computer algebra system while keeping the code as simple as possible in order to comprehensible and easily extensible. SymPy is written entirely in Python. Let's see some examples of using SymPy for symbolic mathematics for demonstration. Here I am presenting the demonstration for using Python for symbolic mathematics. So how we can use this environment for symbolic mathematics? This will be the very short presentation for your use, and all the lectures will be based on this way. We will try to present all the content which will be very helpful, and this will be hands-on practice. See, for symbolic mathematics, first we need to import SymPy, which is the one of the library which deals with the symbolic mathematics, and it is very quite simple to import SymPy. So we have to insert this statement. SymPy library will be imported by using this statement. Now first we need to declare the variables which will be involved in our calculus operations. Here I am using the x variable. X is equal to symbols variable has been assigned at this place. Similarly, we can assign one. We are taking one more variable which is y, and when you will enter, second variable has been assigned. If you want to declare more variable in the single statement, we can do. You can see here, suppose that this is the z, and other variable we have is t, and when you will enter at this place z and t, when you will enter, you can see here two variable and or more than two variables we can assign in the single statement. So these are the variables which we have assigned at this place and will be the part of our calculus. See, in the same pattern we can clear the functions for calculus just by choosing at this place. We have f is one function and j is another function, and also suppose one more function we are taking h, and at this place we have f, g and h. These are the three functions which we will use for our calculus operations. F is equal to, suppose we are assigning one function which is sine x square. This double product represent for is used for the exponent in Python. So this is x square, and when you will enter, we have f function. If you want to differentiate, this is very quite simple to differentiate, and it will return the value. We are using here diff function. This function is used for differentiate f with respect to x. This statement will differentiate the above f function with respect to x, and also we are using here print command. Print, this will print the output and close it. So you can see this is the derivative of this statement. F is equal to sine x square, which is 2x cos x square, and this is the output of the above. See once again, first I am importing here, import SymPy, and then I am declaring the variables. X is there, then then y, this is the y variable. So we have x and y, these are two variables for symbolic mathematics. Along with that, I have to import also from SymPy import. This will help us to use for different type of operations. Suppose that I have f is equal to sine x square plus y square. This is the function of two variable, and I wanted to differentiate f with respect to y, and also I need to print this one. I'm using the print function and enter. So you can see this is the partial derivative of f with respect to y, which is 2y cosine x square plus y square. Similarly, if you want to differentiate f two times, this will return the second order derivative. This is the second order derivative of f with respect to y. And if you are doing, you can do in like in this way also. If you are writing here y, this is also the second derivative of f with respect to y. You can see this output and this output both are same. So either you can use for second order derivative like in this way, or you can write y two times. Similarly, we can use, if you want to differentiate f with respect to x and then with respect to y. So this is the mixed partial derivative of f of second order with respect to x as well as with respect to y. So when you will enter, you can see this is the mixed partial derivative for both the variables. If you want to integrate f with respect to x and enter. So this is the integration of the above function, which is sine x square y square with respect to x. And similarly, if you want to integrate with respect to x then with respect to y, this is a double integration, and when you will enter, we have the corresponding output of the above. By using Spider, we demonstrate several examples associated with the symbolic mathematics. In this course, you will learn about Python packages, Anaconda, Python editors, for example, Python idle, Spider, PyCharm, Jupyter Notebook, etc. Also, you will learn about basic Python program, built-in functions, Python standard library, packages, modules, matplotlib for 2D and 3D plotting in Python, matrices, calculus, solving equations algebraically, solving differential equations, and basics of optimization technique. This course is very informative and supportive for computing symbolically. Thanks to see this video till the end.